Good afternoon, everybody. So I'm Caitlin, and welcome to our first SAEON seminar for the year. Just a few things before we get going. Please, can you keep yourself muted? I think most of you should be muted now, but we'll have an opportunity at the end for you to chat to Mpho and ask any questions you have, and that kind of stuff. And then also, just so you know that this is being recorded and we're going to pop it on the SAEON YouTube page. So if you want to have a look at any of our old seminars, you can find them there. So today we are joined by Mpho Sadiki, and she is a Earth observation data scientist at Digital Earth Africa. So she works with satellites and geospatial data to try and support environmental science and monitoring and things across Africa. And just a little note, she's got a special interest in wetlands. We're really grateful that she was able to join us towards the end of last year at our SAEON GSN in Libano, where she did a workshop for some postgrad students. And we're lucky enough that she's joined us again today. And she's going to be chatting to us and share a little bit about some of the work that Digital Earth Africa does to support environmental research at a continental scale. So I'm going to hand it over to Mpho.
Thank you, Caitlin. Good afternoon, everyone. As I've been introduced, my name is Mpho Sadiki, and I'm an Earth observation data scientist at Digital Earth Africa. And today I'll be speaking to you about how Digital Earth Africa is supporting environmental science through continental scale Earth observation, with a particular focus on how these capabilities align with the kind of long-term environmental monitoring and research that SAEON, organizations like SAEON lead. So the key idea here is that I want to convey that Digital Earth Africa is not just a data platform, but rather it enables, it's an enabling infrastructure that makes consistent analysis-ready Earth observation data accessible for science, decision-making, and collaboration across Africa. So at the core of Digital Earth Africa is a very simple idea, and that idea is that we want to provide a routine, reliable, and operational Earth observation service for the African continent. And the emphasis here is on operational. It's not just an ad hoc analysis or one-off project, but rather a sustained access to decision-ready satellite data that can be used by people from different backgrounds, be it scientists, policymakers, the private sector, and civil society. So the aim is just not to deliver data, but to enable an ecosystem for innovation across sectors where the same consistent data sets can support research, planning, monitoring, and long-term environmental assessment. So this vision is implemented through a set of core thematic areas that we can see visualized there on the screen. And these are because they respond directly to major social, environmental, and economic challenges across Africa. So they include agriculture and food security, water resources and flood risks, land degradation, urbanization, as well as coastal erosion. We are not limited to these thematic areas, but these are the main drivers of the work that we do at Digital Earth Africa. To support this vision, Digital Earth Africa is built on a deliberately robust technical foundation. So we operate one of the largest global implementations of the Open Data Cube, which is entirely cloud native. In more practical or simple terms, this means that the satellite data, products, and services that we provide are stored, organized, and indexed as a single time-aware data archive that allows you to query and analyze decades of imagery as continuous spatial and temporal data sets rather than as individual scenes. So anyone who uses Earth observation data knows that it is a nightmare for you to look for appropriate scenes for your analysis. So this data cube implementation removes that barrier. So this platform is designed to handle very large volumes of data efficiently. In fact, we hold almost 7 petabytes of data on our data cube. So you can just imagine how much data that is. And if you were to try and host it yourself, how much effort that's going to take. So I'll explain to you how we're able to actually hold such a large archive of data in the next slide. So at the continental scale, we host what we call, we host long-term satellite archives that cover the entire continent, including the islands. And we do this across different sensors as well as across time. So if you look at the Landsat archive, we're holding the archive from the 80s, 1984 in some parts of the continent. And most importantly, all the data sets are free and open, included for commercial use. So you could start a business and leverage the power of Digital Earth Africa, be it through the data provision or through analysis platforms. So an important part about what we do at Digital Earth Africa is transparency. All of the services that we have are co-designed and implemented with full visibility. So from the original data, the satellite imagery that we have, to the final products that we give to the users, everything is open and reproducible. And finally, because we recognize that people have different levels of skill, we offer multiple interfaces, from a simple map that you can use for exploration, more advanced programming supported through our sandbox environment. And we also support this through a free online learning platform and an active help desk to support users as they work with the data. So as I said, there's something very central to how Digital Earth Africa works, and that is the Amazon Sustainability Data Initiative. This is how we're able to have this large archive of data in the Amazon Web Services platform. So what this initiative does, it provides free access to large-scale Earth observation and environmental data sets specifically to support sustainability and climate research. And the whole idea is they want to remove the cost and infrastructure barriers that limit people who work with large volumes of satellite data. So through the cloud-hosted storage that Amazon Web Services give us and the scalable computing infrastructure that they also provide, as a researcher, as a practitioner, as a normal person in society, you're able to analyze a lot of data at scale without needing that local high performance computing resource. And this is very important if you're working on a continental scale, maybe even at a country or regional scale. And it allows you to also do multi-decade studies. So this model ensures that the open data that is available around the world in terms of Earth observation, all that data and the tools are available to anyone on the continent who has the interest. So it really accelerates scientific research and encourages collaboration across institutions and regions. Now, this graphic here, I like to include it in presentations because it illustrates how Digital Earth Africa turns raw satellite data into usable environmental information. So at the base of the system are these satellite observations from multiple sensors. We're talking Sentinel-1, 2, 3, 5P, the entire Landsat archive, as well as others that you'll see when I carry on with the presentation. So these are ingested into the data cube where they're organized as a spatial and temporal data archive rather than individual scenes. And because they're structured like that, it allows you to generate analysis-ready data sets, indicators, derived products that are comparable across regions and across years. So from there, these data feed directly into higher level insights such as environmental indicators, monitoring products, and decision support tools. So that's why I like to include the idea of transforming data into insights. So in this next section, I'll focus on the data and services that Digital Earth Africa makes available. So we host a repository, or in that data cube that I was just talking about, Earth observation data sets spanning the entire continent. These data sets are processed in a consistent way, thanks to the power of the data cube, across space and time. So it makes them suitable for continental, regional, cross-border, national scale analysis. And in the next few slides, I'll highlight the types or the different data sets and services that are most relevant or most popular within the environmental sciences and how these can be used to support long-term monitoring research and decision-making. So as I said, we're delivering continental scale services, and we do this to empower climate action. by turning the Earth observation data into decision-ready information. And I already mentioned before that these are developed in close collaboration with scientists, government agencies, practitioners, and partners across the continent. I believe some of our partners are actually on this call right now, from Senegal. So we don't just create these data sets for the sake of creating them because we want to, but rather we engage the users and determine the user needs and rather respond to what the continent requires. So while they're continental, these services produce or provide you with locally relevant insights because they're built on consistent processing across the entire continent. And this is important because it allows for environmental change to be assessed in a way that is comparable across regions. What you do on one side can be compared to what you do on the other side of the country if you're working on the east or the west. And on the screen, we can see some of these services that we have. We have the geomedians. I really love these. If anyone has been working with optical data, you understand how much of a nightmare cloud cover is. So these geomedians are created to combat that issue. So they're composites that provide cloud-free representative imagery that supports a different range of environmental analysis. So we have them at multiple scales. We have them at annual scale, so you have a cloud-free image for the entire year. We also have them at semi-annual, where you have an image for January to June and also July to December. And also what we call a rolling geomedian, which uses a 3-month window to create an image for a single month. So for instance, you're looking for an image for a cloud-free monthly image for June, that would be produced from imagery that spans from May, June, and July to create that rolling geo medium. We also have things like fractional cover, which helps quantify vegetation condition and ground cover as well. One of our most popular products, water observations from space, which enables you to monitor surface water dynamics, including seasonal variability, as well as long-term trends. This one is very popular. So when I go through the example in depth, you'll be able to see how you can interact with it, what kind of information you can also get from there, and how we managed to build on top of that water observation from space to create what we call the water bodies monitoring service, which supports consistent tracking of lakes, dams, and reservoirs. In fact, this water bodies monitoring service, you also see when I explain it a little bit later, it's growing even further to include water quality in the next few months. So that's some of the work that we have as continental scale products. Let me not forget the coastlines monitoring service, which enables you to analyze the shoreline change as well as coastal erosion for not only national but also regional scale. So we have this for the entire African coast, and we cover the islands as well. So together, these services demonstrate how continental scale Earth observation can be translated into information that supports environmental science, climate resilience, as well as policy relevant decision making. So I spoke about how we provide satellite imagery. A very important aspect about the satellite imagery that we do provide is what we call analysis ready. So when we talk about analysis ready, we're talking about imagery that has been processed according to a defined standard so that it can be analyzed immediately. So this includes steps such as geometric correction, radiometric calibration, alignment across space and time, and this ensures that the imagery is consistent and comparable for scientific analysis. So when you get this imagery, you don't have to go through the process of getting it ready for your analysis. In fact, you don't even need to know what that pre-processing process is because that has already been done for you, and it's done for the entire continent. So it means that there's consistency in the pre-processing. And we know this because preparing satellite imagery for analysis is a nightmare. Think about going scene by scene, doing all these corrections, and then bringing it all together to do your analysis. It takes forever. But the power of the data cube and analysis-ready data removes this hurdle for you. So it reduces a lot of the burden that comes with analyzing and using Earth observation data. So we rely heavily on the free ARD, satellite imagery from the international programs such as Landsat. Like I said, with the entire Landsat archive, as well as Sentinel-1 and 2 from the European Space Agency. We're also just finalizing bringing in Sentinel-3 and 5P onto our data cube. Some of it is already available, but some of it is not. That's why I'm saying we're finalizing it, but that's another set of data that you can find on our platform. On top of that raw imagery, we do create these value-added products. I briefly touched on the water observations from space, which is one of our core Continental services, and is a perfect example of how analysis-ready satellite imagery is translated into long-term environmental insights. So what the service does is it provides you with information on surface water dynamics across Africa over the past 3 or 4 decades, so since the 80s. So it offers you a consistent continental coverage that makes it possible to examine the patterns of water availability at local, regional, and national scale using the same underlying methodology. So it identifies areas where water is persistent, where water is seasonal, and where water is rare or episodic in nature. So this distinction is crucial for understanding hydrological variability, perhaps wetland dynamics, flood behavior, and long-term change as well. So as I already mentioned, the service is generated from the Landsat archive from 1984 to present, and each pixel in each image is classified as either water or non-water, and these classifications are combined over time to describe how often water has been observed in a given location. Because of the analysis that is consistent across time and space, you're able to detect long-term trends in surface water presence and variability. This provides with a robust, comparable information that supports environmental monitoring, water resource management, and disaster response. This water bodies monitoring service builds directly on the previous data set that I was just, or service that I was just talking about, water observations from space. So while water observations from space tells us how often water occurs, the water body monitoring service uses that information to identify and track individual water bodies across the continent. So using that more than 40 years of satellite observation, it identifies over 700,000 unique water bodies across Africa. So these include natural lakes, ponds, man-made reservoirs, wetlands, or sometimes even mapped segments of river systems. And this is a service that is operational, so we update it weekly and maps both persistent and seasonal water bodies, as well as changes in the surface area of a water body over time. So if you look at that image, you'll see that for a specific water body, what the water body service does is it gives you that time series at a click of a button. So you don't have to go do an analysis on how this water body is changing over time. That time series is done for you automatically, and we update it weekly when new satellite imagery comes in. So when you click on, or when you click or select a water body of interest, that polygon, you're able to get a graph that tells you its behavior over the last 40 odd years of available imagery. So this is a very nice product that we're currently building on top of to prototype what we call the water quality service. So it'll be built on top of this one. So you won't only be able to see the water extent, how that changes, but you'll also be able to view how the water, the different attributes of water quality, which could include the chlorophyll A, the turbidity, and the likes. So that should be out in the next few weeks. So look forward to that. Another one exciting service is the coastlines, which provides us with annual shoreline positions, as well as rates of change across the entire continent. It's been generated from Landsat as well. From the year 2000 onwards, it's an annual product, so we update it every year. So at the end of 2025, we're supposed to now create a shoreline for 2025, now in 26. So that will be released usually in the second half of the year. So it's an annual product. It's not as frequent as the water bodies. I don't think it needs to be. But yeah, that product that it does exist. So it combines imagery, that Landsat imagery from Digital Earth Africa archive with tidal modeling to map the typical position of coastlines at approximately mean sea level for every single year. And by doing this consistently over time, it becomes possible to examine trends in coastal erosion or growth at both local and continental scales. Because the shoreline positions are mapped every year, this data set allows us to distinguish between short-term changes driven by specific events such as a storm or human intervention, and more gradual processes of long-term coastal change. And this is critical for understanding coastal dynamics and for informing planning, management, and the future scenario assessment. So we will go through how you can actually currently access this product a little bit later on. So you can look forward to that. This service also includes quantitative rates of change statistics. So these are calculated over 30 meters along rocky coastlines by regressing the annual shoreline position through time. And negative values will then tell you that the coastline is retreating or eroding, while positive values indicate coastal growth or coastal growth. Yes. By default, only statistically significant trends are shown. If it's not significant, that will not be shown. So to support the broader scale interpretation, this data set also includes coastal change hotspots. So these summarize patterns of erosion and growth using these moving windows at scales of 15 kilometers, 5 kilometers, and 1 kilometer to make it easier to visualize regional and continental scale patterns of coastal change. While we do these continental scale services, we also do what we call workflows. This is an example of that kind of workflow where we are building a set of notebooks. You'll get to understand what I mean by set of notebooks a little bit later on, because I'll go into that. But we basically create a workflow that anyone, anywhere on the continent can leverage the power of not only the data cube, but also AWS infrastructure to, for this particular case, map and characterize wetlands. We also have a similar workflow for crop type mapping, which you can also get into. So the idea is it will take you through the sampling process, any preliminary outputs that you need to create before you do your feature engineering, your training of your machine learning, as well as your classification. So this is something that we also do in addition to continental scale products. This next session that I'll go into will look at the platforms that you can then use to explore, access, or analyze any of the data sets or use any of the workflows that Digital Earth Africa has. As I mentioned at the very beginning, we have a suite of platforms that are designed for different levels of technical expertise and different use cases. So from simple visual exploration to advanced programming, we support all of that. Because the key is flexibilities. Users can engage with the underlying data through different interfaces that best match their needs, skills, and resources. So the very first one that I like to go through is the Digital Earth Africa map. This is just an interactive visualization map that provides an easy way for you to explore satellite imagery and decision-ready data sets, all the things that I've mentioned and a lot more that I did not get into. If you just want to see these products, this is the platform for you. So it allows you to visualize the data spatially and through time, making it possible to understand not only the geographic patterns, but also variability and change without needing any specialist technical skill. So this platform, like I said, is particularly useful for data exploration, maybe for communication and initial analysis, and often serves as just that starting point before you move into a more detailed the more detailed workflows that we have. I'll show this platform and how you can use it in a few minutes. I also like to mention that everything that we do is documented. So all the documentation for our data products, for our notebooks, for our workflows we have them documented through the Digital Earth Africa user guide. So this brings together documentation for both the data and the tools that we have available on the platform. It provides you with an overview of the data sets that we host, as well as any of the data sets that we create, the science, the logic behind all of it, links to where you can get the code should you want to do it yourself. All of that is included there. So for anyone who's new to Earth observation, this is also an entry point where you can look at how to get started with Earth observation based on the explanations that we give for all our data and all of our products. And if you just want to know more of the technical detail and references that support these analyses and the workflow development, this is the place for you to go as well. I'll also showcase this a little bit later. My favorite part, which is a big part of my day-to-day, the notebook repository. We maintain an open notebook repository that supports hands-on analysis and learning. So it includes, I will say 150 plus, but it's way more than that at this point. These are open source notebooks that cover different topics and support different sustainable development goals indicators. And they support a wide range of applications, which can range from agriculture and food security, water resources and flood risk. So under that blanket of thematic areas that I mentioned in the very beginning. So they can also introduce you a little bit into machine learning and open data cube workflows. So these notebooks are designed to support users at different levels as well. So for beginners who are new to satellite data, through to advanced users supporting custom analysis. So if these notebooks don't meet the requirements or the need that you have, we're more than happy to help you tailor them or build one from scratch that will meet your needs. So with that notebook repository, it's automatically loaded into our analysis sandbox. So actually, let me talk about the repository being on GitHub first. So it's loaded, it's hosted on GitHub. So it's open source. You can access the data, you can access the code. If you want to use it through our platform, you can. If you want to use it outside, you can. If you want to use it for commercial use, all of that is available to you. And this is the link to that GitHub repository, as well as other repositories that you can see there, including that crop masking. If you just go to the Digital Earth Africa GitHub repository, you'll be able to see a lot of repos underneath that you can explore and see how we're doing things. You can use them for whatever needs you have. And these notebooks are automatically loaded into our analysis sandbox environment. So if you want to do analysis and you don't want to do it outside, you want to do it within the Digital Earth Africa sandbox, we provide an environment for that, and we call it a sandbox. You get to play around in the sandbox. It is a cloud-based computational environment that runs through Jupyter Lab and is tightly integrated with the Digital Earth Africa notebook repository. So these notebooks that you saw in the previous slide are loaded by default into this environment. So it allows you to move directly from guided examples to your own analysis. It is a limited free compute resource, but it's really it's enough. You will not need more than what you're being given. And if you do, you reach out to us and we can see how we can assist you with that. So once you sign up, you will have technically 2 free computers. You get a 16 gig one and a 32 gig one, and you can use them however you want for your research. Even if it's for business, you're welcome to do that. So it enables you to access all that data directly from that data cube that we have with over 7 petabytes of data, and also have access to those notebooks that we've written with these tools. And then you can go into that exploratory analysis, looking into getting started with analyzing satellite imagery. So for many users, it serves really as a practical bridge between learning, experimentation, and applied research. I'll also showcase this in the next few minutes so you can see how you can get started. In addition to all those platforms that I've mentioned, the sandbox, the maps, there's other ways that you can interact with the Digital Earth Africa data. Like I said, it is hosted on Amazon Web Services in publicly accessible S3 buckets. So they're available for direct cloud-based access. So users can work with the data and anything directly from that storage. You don't necessarily have to come through the Digital Earth Africa platform. You can, so for programmatic workflows, you can the data is stack compliant, so you can load it as X-array data sets wherever, in whatever environment, Python environment of your choice. And this supports integration into existing research pipelines if you already have them, and high performance or cloud computing environments that you're already using. So you don't need to let go of those, but rather you can just leverage pulling that data from those buckets that we have available. You can also access them through standardized geospatial services. Some of it is available through the Esri Living Atlas or ArcGIS Online. You can also use web map services and web coverage services, allowing you to get that data directly on your desktop on ArcGIS or QGIS. So together, these ensure that the data is flexible to use in different contexts. You don't have to be restricted to the Digital Earth Africa platform. So if you want to get started, you're not sure how, one of the best ways is through the Digital Earth Africa learning platform. We have this to help users build skills and confidence and get started with Earth observation. The platform is free to access and it's completely fully self-paced. So you can sign up, enroll in a few courses, such as the introduction to the analysis sandbox or more advanced master classes, depending on your experience level. There's also training materials, videos, recorded tutorials, manuals, and hands-on exercises that are available in English and French, and sometimes in Portuguese. Portuguese is not always guaranteed, but English and French are guaranteed. And on completion, you are even able to get a certificate of completion if you would like one. And in addition to these self-paced trainings that are available, we host weekly live sessions. So every Wednesday in South Africa, it'll be 1 p.m., so 11 a.m. GMT. We host them on Zoom in English and French. So if this week is in English, the next week would be in French. So if you want to join those, you can. And in these sessions, they're run by our capacity development team. And occasionally you will have guest presenters, and sometimes some of us from the science team will join, and you get the opportunity to learn directly from us and ask questions. If you have any concerns, those will be addressed there. So if you're interested, please do leverage the learning platform. And before I wrap up my presentation, I will just showcase some of the links. Caitlin, if I can just make sure you're seeing my web browser and not the presentation.
Yep, you good.
Great. So obviously we have our website, and from there you can navigate to most places. If you want to go to the platforms, you're able to go to them from here. So if you want to go to the maps, you can just go there. This should open this for you where you can get some explanations about the different ways of access that I just explained. So I will open the maps. So I will just show one brief example, perhaps with that water bodies product. So when you open it, you don't need to log in. It's completely open. Just close that. You can search locations. So if you want to see different data sets, you just explore. You'll see two main categories where we have DE Africa Continental Services. These are services that we have created. So those value-added products that we've created, those fall under that category. If it's external, it's anything that we bring in from somewhere else. So including the satellite imagery itself, because we don't have a satellite moving around in space, capturing the imagery, it's external to us. So you would find that under here. So if you go satellite images, you go find the radar backscatter, you'll find surface reflectance where we have Sentinel-2, we have Landsat 9, 8, 7, and 5, and soon there will be Sentinel-3 and 5P included in here. So this is how you would actually interact with the data. But I think for the example, I'll showcase the surface water bodies. So when you click on it, you add it to the map. You'll see with this one, it's it's a vector product. We don't usually have those, but this one is a vector product, and it's loaded over 700,000 polygons that you can then interact with. So let me just go to Pretoria so I can pick one. I'll just pick a water body so I can show you the time series, how quick it is. You don't have to go download the imagery, do your modified, normalized difference water index. Just click on the water body and your time series already exists. And you can expand it where if you'll see it there. Obviously, everyone knows that pre-2013, Landsat imagery is not great, doesn't have great coverage for Africa, so that's why there's a lot of gaps. But you can see after that, there's pretty good coverage, and you can see the percentage of wetness, so 0 to 100, that's the orange, and then the area of wetness in square meters that is given to you in the green. So you can have different options to showcase there. But one thing I did forget, how we determine the size of the water body is they take the time series and they calculate its maximum extent. So all that imagery from 1984 to present, and it's not done every day, but every once in a while, we recalculate it to get the maximum extent of the water body based on that time frame, and that then becomes the 100%. And then this graph is then put against that 100% based on the maximum extent. But if you understand a little bit more, if you go to the Digital Earth Africa, this docs pages, you will find it there. All you have to do is open the page. The entire logic behind that product is included in here. So you would be able to understand how we determine maximum extent, how we then do, how we account for cloud coverage and all of that stuff. So that first one was the maps, and I've just showcased the docs. I'll also share this presentation. All these links will be included in the presentation, so you would be able to go through them yourself. But the sandbox, which I love very much, when you sign up, which is a very simple process, put in your details, and then you get a verification code, and you're in. This is what you'll get. You'll get the beginner's guide. This is where you're not completely sure what you want to do. You go into that and you see a set of notebooks. And if you open one, just double clicking opens it. You'll see it takes you through what a Jupyter notebook is and how you can work with it. Everything, there's instructions like we're 5, so you wouldn't be confused by much. But if you are, you're always welcome to reach out to us and we can assist you in any way. So this folder is for when you're getting started and you want to just figure out how to get yourself started. Once you're done, there's a datasets folder. All those datasets that are included on the maps that we have documentation for, how to interact with them, how to load them from the data cube, how to bring them into the environment, how to plot them, what measurements are included, those are included here. So you see there's one for Sentinel-1, 2, 3, 5P. If you have soil moist, there's a notebook for all of that. There's also a set of notebooks for frequently used code. This is when you want to do something and you're not completely sure how to do it. Maybe you want to download a GeoTIFF and you don't know how to do it within the sandbox environment. This would take you through that. But my favorite part of the sandbox happens in the real world examples. This is where we actually have actual examples of analysis that we're doing. It's not the best of the best, but it gets you started. And if it doesn't meet your requirements, you can always perfect it, make it better. And if you're not sure how, you reach out to us. We tailor those changes to your needs. So you'll find things like looking at burnt area mapping, intertidal elevation, crop health, rainfall anomalies, looking at water extent changes using Sentinel-2 instead of Sentinel-1. There's a whole bunch of things that you would be able to look at in the sandbox. So if you do get a chance, please go into it. If you want to go through the learning platform first, please do. But if you want to you want me to help you or our capacity development team to help you, that's also fine. You can reach out to us and we will help you the best way we can. Okay, let me just share that presentation again. Okay, so I can't end this presentation without acknowledging our partners and organizations that make Digital Earth Africa possible. So these are our partners, our funders, our collaborators. So we have to appreciate the hard work that they put in to make it all possible for Digital Earth Africa. So as I wrap up, I would like to open the floor for discussion. If you have any questions, please feel free. If you want to talk to me later, that's also all right. My email will be on the presentation, so you can email me later. So I would like us to just feel free to speak, have a discussion. If you see anything that would be useful to you, that would be great to know. If you see any areas where you would like to explore and see if we can come up with something together, that would be great to understand as well. So I would like to hear what your needs are and how Digital Earth Africa can potentially assist. Even if it's not covered here, there might be room for us to speak. And if you want us to collaborate, we love collaborations. And as I said, it's not for a fee. We just want to advance the use of Earth observation on the continent. Thank you very much. Please feel free to ask me any questions that you might have.
Thank you so much, Mpho. That was a lovely overview of all the cool things that you guys have going on at Digital Earth Africa. And it's cool to see how all like the learning stuff as well, how it would be such a nice, like someone in the comments said, it would have been nice to have this when they were doing their PhD and stuff. And I think a lot of people have gone through the pain of figuring out stuff, and it's so cool that there's all of this information in one place, which is really, really nice. So yeah, as Paul mentioned, we're opening up to questions. So will you just raise your hand so we can not all talk at the same time? But yeah, if anybody's got questions, just wants to chat to her, yeah, please just raise your hands and we can go from there. Oh, there's one in the chat here. Debbie, would you like to unmute and ask your question?
Thanks, Caitlin. So, I mean, I'm just amazed at this product, and I just want to thank you guys for making this available. With the water extent that you showed us, what happens when you get a new maximum extent of water? So, for instance, I'm thinking of the recent Kruger and current Mozambique floods, where it's, I think, probably one of the worst that in that period. How would you then, is your data then automatically adjusted for that new maximum that might have occurred?
Yeah, so with the maximum extent, it's not something every time we update the time series, we don't always update the maximum extent. That's done maybe once every 2 years or something. It's not something that we do. And when you do that maximum extent, you do have to account for anomalies. So things like that, where there's extensive flooding in the Kruger, that would not count as the new extent if it's done, let's say, in 2 years, because that would clearly be an anomaly in that time series. I hope that answers your questions, Debbie.
It does. Thank you.
I see there's also a question about what is the most recent analysis ready data available? What year? So with Sentinel 1, 2, Landsat, as soon as an image is available in the original pipeline, so at USGS and ESA, it takes at most 5 days for it to be available within our data cube. So the best way to see if the data is available for your area of interest is to use that Maps platform. Just zoom into your area, load the Sentinel, because as soon as it comes in, it will then appear in that platform as well. So you can see what is available for a specific time. Yeah, great.
There are a few other questions in the chat. Joshua, do you want to unmute or would you like me to read it?
No, thanks. Paul's just covered my question. Thanks.
Sorry, I missed it. Nanette, would you like to ask your question?
I just want to say thank you so much, Mpho, and you speak so lovely. I enjoyed it so much listening to you, and it's so interesting. So I'm definitely going to play around in the sandbox.
Ah, I
Hopefully
love to
not
hear
building
that.
sandcastles.
That's great. And if you need any assistance, feel free to reach out. We're
I
more
will
than willing to
definitely.
help.
Thank you, Mpho. Thank you,
Great. Thank you.
Caitlin.
Anybody else have any questions?
Yes.
Eugene,
So
would you like to ask her? Okay, go.
So yeah, for the climate data, we already have chirps. If you go on the Maps platform, you'll be able to see that we already have chirps. Although we don't include it in there in the um, platform, the Maps platform, you will only see, I believe, I don't know if it's a daily or the monthly one, but we do have both. So you can access them through Digital Earth Africa. And we also have ERA 5, some of the attributes you can also access through us. Although we don't host them on the data cube, we make a way for you to bring them in. I hope that answers your question, Eugene. Great. And Lebohang, so is the water body layer classified into types? No, it is not. But if you would like to, that's something that I could probably assist you with because my interest is in wetlands, and that wetlands workflow is something that I worked on. So we could come up with a workflow for you to do that if that's something you're interested in. But it doesn't say whether it's a lake or a wetland. That's up to you to decide because there's no way we can validate the entire continent, so we don't even want to try. So that's how it is. And Debbie, on land cover categories included in the land cover maps. So the land cover maps, none of them are ours. So you'll see they fall under the external data sets. Let me just get the correct names, but we have three. We have obviously the ESA world cover. We have the Copernicus land cover. We have the Esri global land use land cover. So those have different categories that are not up to us. Unfortunately, we just post them for you to be able to use. But if you do want to do your own land cover classification and you have some training data that we can put into a workflow of some sort, we could help you, and you can obviously then decide what classes you want to include. But right now, with the ones we have available, they're not ours. We're just hosting them for easy access. I see there's a question for Michael. Does the analysis factor in possible reasons that may affect changes in water bodies, be it quantity, such as construction, obstruction? Yeah, no, we don't do that. So we just get the extent and we'll be getting the water quality. The whole idea is once you showcase a pattern, we're then able, the relevant people who should look into why that is happening can do that. But if you have a specific use case, Michael, that you want to work on, that wants to look at that and you want us to support, 100% we can support. But we don't have that at a continental scale to say, we're sure that this water body is shrinking because of over extraction or there's damming of the river or something like that. We don't do it, but it is possible, obviously, through a more user-centered use case. So if you want to do that and you want us to help you with anything, feel free to reach out to us. So Lebohang also has a question on the storage. So the 16 and 32 is not the storage. You have very limited storage actually available to you, but that is the memory that you have available to be able to run your analysis. If you're running into problem with the 32, because 16 can do most things, reach out to us. We're trying not to just hand out big computers so people can mine Bitcoin. So if you want help, we can help you optimize your code to do better within that 16 or 32 gig that we have available for you. what kind of data do you need to validate land use, land cover classification? So the way we do it, we usually follow the same kind of thing that you would follow with any sort of basic machine learning training, where you have you train your algorithm and you reserve some of the data for validation. Because we don't have a continental land cover map, I can't say how we validated that, but if you have a specific use case, you would obviously need data to train your model, and some of it reserved to validate that output. I don't know if that at least answers something. Okay, great, Moses. And since you mentioned issues of validation, is it open for individuals to send through? Yeah, we sometimes, for instance, when we're doing this water quality stuff, we did reach out to some people that we know would have water quality data that we could use to validate the products. If that's not possible, we usually have partners across the continent that go out and help us with getting validation data. But if it's your own specific project and you have the data, 100%, you can share it and we can help you work with it to do that. And Eugene, who is funding us? So this is a question as everybody else. Yeah, we are not for profit. We're completely funded. Our main funders are the Helmsley Charitable Trust. It's a trust in the US. They're very generous. They like to do climate work, and we like to do climate work for Africa. So they give us free money for our operations. And we obviously do grants here and there. And the Australian government also, because we technically branched off from a Digital Earth Australia. So they also support a lot of the science work that we do through, especially for the science work, they do give us money to create these continental products as well. And do we offer free consultations or do we get an invoice? Never get an invoice from us. If anyone charges you, they're ripping you off, I'm telling you. So it's all free if you need our assistance. It's not just me, it's a whole team. It's a whole science team, it's a whole capacity development team. If I don't know it, there's someone on the team that knows it. So you can rest assured, reach out to us and we'll help you the best way we can. And we also have collaborations. So if SAEON has a big project going on and you want our help, please call us. Yes.
Perfect. Thank you so much, Mpho. I think you've done a great job of selling everything and selling all the resources you have. Anybody have any last burning questions? I think a lot of these comments were, oh, you did such a nice job, and lots of claps. So yeah, thank you so much. Yeah, I really learned a lot, and hopefully I'll go have a look at some of these things and learn a little bit more about that space. So yeah, and I just wanted to say thank you to everybody for joining us today. And that we will be having our next seminar on the 5th of March. So hopefully you can join us as well. And yeah, thank you, everybody. Bye.